40% of the time squeaking noises are coming out of your face, 60% of the time nothing is coming out of your face. And if we set up a system where it only transmits bits when noises are coming out of your face, and that only happens 40% of the time, well, right there, then we have a dramatic improvement on the actual loading and usage of the long-distance circuits. Because in traditional telephony, 64 kilobits per second, second after second, minute after minute, are reserved on the backbone during your phone call, whether any noise is coming out of your face or not. And if we change that into a system where we only actually transmit bits, possibly at that same rate, when noise is coming out of your face, and knowing that statistically speaking, that's only going to be happening 40% of the time, then we can use the trunks much more efficiently. This might end up being the least of the reasons why voice over IP is cheaper. The premise here is that because the carrier can be more efficient in using their backbone long-distance circuits, they can pass some of those savings on to us. But what kind of savings are we talking about here? You have to look and see, well, how much does long-distance transmission actually cost? And if you take a close look at that, you'll find out the answer is real close to zero. And that's because of a technology called dense wave division multiplexing that's allowed us to dramatically expand how many trunks can be carried on fiber optic transmission systems. And in fact, all of these companies like 360 Networks and Global Crossing and Williams and Quest and on and on and on, they went on all these huge construction programs to build fiber backbones. And then this technology called dense wave division multiplexing exponentially increased how much you could carry on the fiber backbones. Because of this overcapacity, the cost of transmitting stuff long distance for a carrier is very close to zero. So when we start talking about voice over IP is going to be cheaper because we're being more efficient, well, that story starts sounding a bit weak when you find out that the actual cost of transmission is pretty close to zero. Bypassing the local exchange carrier and initially at first avoiding regulatory fees are the reasons why voice over IP is going to be cheaper than regular telephone service. And let's not forget the idea of competition. Because if you want to take sort of an empirical view at this story that we're talking about right here, voice over IP long distance via cable modems, what this essentially is a move by the cable companies into the telephony business. And of course, then the telephone companies have to jump in and say, well, we're going to do this too. Because otherwise, they're at risk of losing a big chunk of their business to the cable companies. The phone companies don't want to do this. It's going to cost them a huge amount of money, and their revenues are going to end up dropping because of competition. But they have to because the cable companies are jumping into the story. Besides being cheaper, another reason for doing this would then be the deployment of value-added services. And an easy example of that would be caller ID. Not just delivered in real time to a little screen on your telephone or possibly popping up on your TV, but having a server that stores a log of the people who've called you and then being able to use your browser and the internet to access that server and see a list of your calls on a web page. So that'll be a service that'll be added. Maybe it'll be free from the cable companies at first, but I know that where I live, they charge $5 a month for caller ID, and then they charge extra if you want the name delivered. You can imagine that this sort of service where you get caller ID logs on the web might be free at first, but that's going to end up being a cash cow for the service provider in the long run. Another flavor of what somebody could mean when they say voice over IP is this story, a voice over IP based inter-exchange carrier. Now this kind of turns the tables from our first scenario. Here there are no computers involved. People at both ends have regular telephones and plain ordinary telephone service. And they sign up with an inter-exchange carrier to do long-distance communications. But this inter-exchange carrier does not provide circuit-switched DS0 service, which is what normal telephony is. Instead, this inter-exchange carrier takes the streams of bits that it receives from the local exchange carrier and puts them in IP packets and transmits them as voice over IP long distance to a far end city where they have a gateway that can convert the voice over IP back to a regular phone call to give it to the local exchange carrier to deliver it as a regular phone call to the customer on the far end. The application for this type of communications, well, it fits into the previous scenario with the cable TV long-distance voice communications. Another area where it fits in is to places where it's ridiculously expensive to make a long-distance phone call. And if you go on vacation to some place like in the Caribbean, what we find is that there's an incumbent phone company that's enjoyed a monopoly on providing long-distance communications for the last 60 years. And because they have a monopoly, they've added a huge charge to making long-distance phone calls that then they bring in as profit. And in some countries, the profit that they make terminating long-distance phone calls actually shows up as part of their gross domestic product. And you go to some island in the Caribbean and you want to phone home and you discover that there's only one carrier you can do that with, and it costs $1.85 a minute for a phone call. Well, this is an opportunity for competitive carriers to come in and possibly do so before that country allows competition, because what they can purport that they're doing is providing a data service. So now it's not long-distance voice all of a sudden as far as the regulators are concerned, and lease data service from some company like Global Crossing, and then do voice over IP over this leased capacity and bypass either the local exchange carrier or the incumbent inter-exchange carrier or both, and charge a lot less for the service. And if they're going to be looking for efficiencies on the long-distance circuits that they're paying for to move these IP packets around, then they're going to implement silence suppression using variable rate codecs that we talked about earlier. And they're going to put a whole bunch of people's phone calls together onto the capacity that they're paying for. Now, hopefully, the only way that the user will know in this scenario that they're doing voice over IP and not a regular phone call is that it's cheaper. Another way that a user might be able to tell that it's voice over IP and not a regular phone call is that the sound quality isn't very good. We're certainly going to look at the pros and cons of doing voice over IP in the next chapter and go through all the various purported advantages and the caveats and so forth. But this is probably one of the key ones. What kind of sound quality are you going to get? And that is directly related to what kind of network service is the carrier using to move these IP packets, and are they doing any guaranteed quality of service? And the whole range of possibilities exists, all the way from the carrier having dedicated capacity and carefully monitoring the packets and running some quality assurance techniques on there so it sounds exactly like a regular phone call, all the way down to the carrier paying for a high-speed internet connection and then running your voice communications over the internet between the cities. And with each of the different possibilities that we're going to look at, there's a different expected quality of voice service. This scenario is a hybrid of a couple that we've looked at, and it's a bit different than the long distance over cable TV story. Here we've got a hobbyist at one side and somebody with a regular telephone at the other side. And the hobbyist has some voice over IP software and an internet connection. Could be a dial-up connection, could be DSL, could be cable. And what they do is they go over the internet to some service provider that's got a gateway that will convert their voice over IP into a regular phone call to deliver their communications to somebody who has regular telephone service at the other end. I guess Net2Phone.com Inc. was one of the original big providers of this service, and then there was also Dialpad.com. And you could get this working. You could connect over the internet to this